this element has 3 number of atoms. Question 2. A molecule of neon is, what is neon? Neon is a noble gas with the formula Ne. Here you can see that it's only 1 atom that is here, making it what? Monoatomic. When you have 1 atom in chemistry, it is known as mono. Mono means 1. Therefore, the answer to this question is option D, monoatomic. Question 3 states the law of definite proportion. This has been stated earlier in the contest, and law of definite proportion states that all pure samples of a particular chemical compound contain similar elements combined in the same proportion by mass. Question 4. From the equation of reaction, in which 2 moles of hydrogen gas, 2 moles of hydrogen gas reacting with 1 mole of oxygen gas, 1 mole of oxygen gas to produce 2 moles of steam. 2 moles of steam. Steam is water in the gaseous state and is also known as water vapor. Here, this is the reaction to justify the question number 4. From this reaction, it can be deduced that 2 moles of hydrogen gas react with 1 mole of oxygen gas to give you 2 moles of steam. The questioner asks that we should calculate the number of moles of oxygen gas required to yield 6 moles of water. From the reaction, it can be deduced that 2 moles of water is equal to 1 mole of O2, oxygen. That means 6 moles of water will automatically be equal to, since you have 2:1, then 6 moles of these will be 3 moles of oxygen. Therefore, the answer to question 4 is 3 moles of oxygen. Question 5. If the relative molecular mass of CH2O is 60, calculate the whole number of atoms. It has been established earlier the relationship between empirical formula and molecular mass. Empirical formula is equal to molecular mass affected by N, where N is the number of atoms. From the question, the molecular mass has been given. M is equal to 60 from the question. And the question asks us to calculate the whole number of atoms. Empirical formula has also been given. Now, to go by the calculation, empirical formula is CH2 O. Affected by N makes it molecular mass, which is equivalent to 60. From the question, carbon is 12. Hydrogen is 1, but because we have 2 atoms of hydrogen, making it 2 times 1. Plus oxygen is 16. Everything affected by N is equal to 60. 12 plus 2 times 1, it is 2. Plus 16 affected by N is equivalent to 60. 12 plus 2 is 14. Plus 16, that becomes 30. 30 times N becomes 30N, which is equivalent to 60. To calculate our N, we need to divide both sides by 30, where 30N divided by 30 is equal to 60 divided by 30. Here, this 30 can cancel out this 30, remaining N. This 30 can cancel out this 60, remaining 2. Which implies that your N is now equals to 2. Calculate the whole number of atoms. Therefore, the whole number of atoms is 2. Electron configuration of atoms. This shows the arrangement of electron in an atom using Bohr model or wave mechanics model. Types of bonds. There are 4 types of bonds, namely ionic bond. This involves the transfer of an electron from a metal to a non-metal. What do you understand by metal? They are elements that donate electrons, while non-metals are elements that accept electrons. And a typical example of ionic bond is the bond between sodium and chlorine, which is known as sodium chloride. Here, sodium has atomic number 11, and we have 1 electron in the outermost shell. Chlorine has atomic number of 17, and we have 7 electrons in the outermost shell. This is 1 for sodium. This is 2, 2, 2, 6, 7 for chlorine. Here, the ionic bond that is being established here is the transfer of this electron. This sodium transfers this electron to this chlorine, which accepts the electron to form a bond. So the bond formed here is what is referred to as ionic bond. 2. Covalent bond. This involves the sharing of a pair of electrons between the 2 reacting atoms so that both can attain the stable octet configuration. A typical example of this is found in carbon 4 oxide, where carbon is a central atom. There is an oxygen here, and there is an oxygen at the opposite end. There is an electron for carbon here. There is an electron for oxygen here. There is an electron for carbon here. There is another electron for oxygen here. There is electron for this carbon here. There is electron for this oxygen here. There is electron for this carbon here. There is another electron for the oxygen here. So for this compound to attain stable configuration, this bond, this electron and this electron has to come together in a form of shared pair, as justified in the definition of covalent bond. So they share this electron to form a bond. 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 So this compound is otherwise known as CO2. And this is a typical example of a covalent bond. Number 3, coordinate covalent bond. This is a combination in which the pair is donated by only one of the participants. What do you understand by this? A typical example is